My name is Senuri Fernando. Today I will be presenting on foundation computing, core hardware, data representation and network infrastructure. Let's get started. Training agenda. Our training agenda is built around three core pillars. First, physical systems, focusing on CPU, motherboard, and storage. Second, digital translation, covering binary systems and data representation fundamentals. And third, enterprises connectivity, looking at network interaction and web protocols. Internal components of the CPU. Let's look inside the CPU. It has 5 core components. The control unit directs data flow. The arithmetic logic unit performs calculations and logic, and registers provide ultra-fast temporary storage. Cache memory reduce latency between the CPU and RAM, and the internal clock synchronizes the all operations in gigahertz. Next, explore the operational dynamics functions of the CPU. Every instruction follows as fundamental cycle: fetch, decode, and execute. The speed of this cycle is determined by the clock speed. To handle massive workloads, modern CPUs use multitasking and multi-core processing to run multiple instruction cycles independently and simultaneously. Now looks at the hardware ecosystem and how components work together. No components works alone. The motherboard acts as the central communication highway, housing the CPU, RAM, and expansion slots. The CPU and RAM constantly interact across the system bus. Remember, RAM is volatile, which is why persistent storage is essential. Let's bring this concept together by looking at the system hardware workflow. Here is a practical hardware workflow in 4 steps. First, input. Devices like keyboard capture raw data. Second, process. Via the CPU and RAM, execute application logic. Third, storage. Via processed data is saved to persist media. And finally, output, where results are displayed or transmitted. Moving forward, let's look at enterprise storage media, types and categories. Organization rely on 4 main storage types. Magnetic storage for low cost, bulk archival. Solid state for fast performance critical task. Optical media for software distribution and compliance. And cloud-backed storage for scalability and business continuity. This storage analysis matrix compares different storage technologies based on speed, cost, capacity, and business use. HDD are best for low-cost storage. SSD are suitable for everyday tasks, and NVMe provide the highest performance for demanding applications. Optical storage is mainly used for achieving, while cloud storage offers flexible and scalable backup solutions. The best choice depends on the organization performance needs and budget. This slide explains the binary system, which is the foundation of all computer data. Computers use only two values, 0 and 1, to represent and process information. These values are controlled by transistors that act as electronic switches. The table also shows how data is measured, from bits and bytes to kilobytes, megabytes, gigabytes, and terabytes. Next, let's look at character and text encoding standards. Computers use encoding system to convert letters and symbols to binary. ASCII is an old standard that supports 128 English characters, while Unicode is the modern standard that supports over 143,000 characters, including different languages and emojis. Today, most systems use Unicode because it provides better global compatibility. This slide explains how encryption protects sensitive data. Symmetric encryption uses the same keys for both encryption and decryption, making it fast and efficient. In contrast, asymmetric encryption uses a public key and a private key, providing a stronger security for secure communication. Many modern systems combine both methods to achieve better security and performance. Next, let's look at how digital images are represented in a computer. These slides explain how digital images are represented. Every image is made up of tiny pixels. Image resolution determines the level of detail, while color depth determines how many colors an image can display. Higher resolution and color depth improve image quality, but they also increase the file size. Next, let's look at digital sound. Sound is stored by converting analog audio into digital data through sampling. A high sample rate and bit depth produce better sound quality but also increase the file size. Common audio formats include MP3, WAV, and AAC depending on the required quality and storage. Next, let's discuss data compression techniques. Data compression reduces file size to save storage space and speed up data transfer. There are two main types: lossless compression, which keeps all the original data, and lossy compression, which removes some data to achieve a smaller file size. The choice depends on the required quality and storage efficiency. Next, let's look at logic gates, which are the Foundation of computer processing. Logic gates perform simple operations using binary inputs 0 and 1. Common logic gates include AND gate, OR gate, and NOT gate. These gates work together to help computers make decisions and process the data efficiently. Next, let's look at the fundamentals of computer networks. A computer network connects multiple devices so they can communicate and share data and resources. Common types include LAN, WAN, and the Internet. Computer networks improve communication, resource sharing, and access to information. Next, let's move on to compare network scales and classifications. Networks are classified based on their size and coverage area. For example, a LAN connects devices within a small area, while a WAN connects networks over long distance. Organizations choose the appropriate network type based on their size, communication needs, and business operations. Next, let's look at network infrastructure components. A network is built using devices such as routers, switch, modems, access point, and network cables. These components work together to connect devices, manage data traffic, and provide reliable communication across the network. Next, let's move on to modern World Wide Web technologies. The web uses technologies such as HTML, CSS, and JavaScript to create interactive websites. HTML provides the structure, CSS controls the design, and JavaScript adds interactivity. Together, these technologies create fast, responsive, and user-friendly web applications. Next, let's look at physical and logical network topologies. A physical topology shows how devices are physically connected, while a logical topology shows how data flows throughout the network. Common topologies include star, bus, ring, and mesh. Choosing the ring topology helps improve network performance and reliability. References. So thank you for your attention in my presentation.